All right, let's talk about something that really separates the pros from the amateurs. Error handling. This is the stuff that takes a tool from a simple demo that just works on your laptop to a professional-grade system that can actually survive out there in the wild. So let's get right into it.
And this quote, it really just hits the nail on the head. You're never, ever going to build a system that's completely free of errors. It's just not possible. The real game is being ready for them. It's all about building systems that don't just fall over when something unexpected happens, but can actually recover all on their own. That, right there, is the foundation of resilience.
So, how are we going to tackle this? Well, here's our game plan. First, we need to know our enemy. What kinds of failures are we even up against? Then, we'll start building up our defenses, layer by layer, starting with simple retries and moving to some heavy-duty fortifications. After that, it's all about communication, and we'll wrap it all up with a blueprint you can take with you.
Okay, first things first. If you're going to build a fortress, you've got to know what you're defending against, right? It's exactly the same with code. Not all errors are created equal, and figuring out the difference is absolutely the critical first step to handling them the right way.
So check this out. The most important column here is the one on the right, action. See how it doesn't just say retry for everything? That's key. If you get a client error, like, say, a bad password or a malformed request, well, retrying that 1,000 times isn't going to magically fix it. Same goes for validation errors. But server errors, network hiccups, those are often just temporary glitches. They're what we call transient, and they are the perfect candidates for a retry.
This right here, this is the fundamental divide. It all comes down to asking, whose fault is it? If the problem is on the user's end, they sent bad data, their permissions are wrong, that's a client error. Trying the exact same thing again is just pointless. It's like knocking on a locked door with the wrong key over and over again. But if the problem is on our end, the server is having a bad moment, it's overloaded, that's a server error. That's a hang on a second and try again kind of problem. And that's where we can be smart. All right, so we know when to retry, but that's only half the story. Now we've got to talk about how to retry. Because if you do it wrong, you can actually make things so much worse. Just blindly hammering a service that's already struggling, that's kind of like throwing gasoline on a fire.
And that's where this brilliant idea comes in, exponential backoff. The concept is pretty simple. Every time a retry fails, you wait longer before the next one. You basically double the delay each time. But here's the secret sauce. You add a little bit of randomness to that delay. We call it jitter. Think about it. If a service comes back online and everyone retries at the exact same millisecond, you've just created a stampede, a thundering herd that'll probably knock it offline again. Jitter staggers those retries, giving the service a chance to breathe.
And you can see exactly how it works right here. Attempt 1 fails. Okay, we'll wait about a second. That fails too. Fine. Now we wait 2 seconds. Still no luck? We'll back off for 4 seconds. You see the pattern? We're giving that struggling service more and more space to sort itself out. It's polite and it's way more effective.
And this isn't some super complex algorithm either. Look at the code. The core of it is right there. Wait time is basically 2 raised to the power of whatever attempt number we're on. Then you just sprinkle in a little bit of that random jitter we talked about. It's amazing how a couple of simple lines of code can solve such a massive potential problem.
Okay, so smart retries are fantastic for handling little blips. But what happens when a service isn't just struggling? It's just playing down. For that, we need to bring out the big guns. We need to upgrade our defenses to protect the whole system.
And that brings us to the circuit breaker. The name is perfect because it works exactly like the one in your house. When too much current flows, a breaker trips to prevent a fire. In our software, when too many requests fail in a row, the circuit breaker trips. It just stops sending requests to the broken service altogether. This is huge. It stops your app from wasting resources and, just as importantly, it gives that failing service a much-needed break so it can recover.
So a circuit breaker lives in one of 3 states. Most of the time, hopefully, it's closed. Everything's good, requests are flowing. But when things go bad, we hit a failure threshold, bam, it flips to open. Now it's not even trying to call the service, it just fails requests immediately. Then, after a little cooldown period, it gets curious. It enters the half-open state. It'll let just one single request through, like a little scout. If that request succeeds, great, the breaker closes and we're back in business. If it fails, nope, back to the open state. It's basically a self-healing safety valve for your system.
Now, a circuit breaker is something we build to be a good neighbor to other services. But sometimes services protect themselves from us. That's called rate limiting. And a well-behaved API doesn't just slam the door in your face. It communicates. It sends back a response like this one, with a retry after key. It's literally telling you, hey, I'm swamped right now. Please wait 60 seconds before you try again. A smart, resilient client listens to that. It doesn't guess. It obeys.
So, we've got these great mechanisms for reacting to failure. But that's not enough. To build something truly robust, we need to be proactive. And that all comes down to intelligence and communication. Good error messages and detailed logs, they aren't just for us humans to read later. They can actually help our systems fix themselves.
Okay, so what does an intelligent error message even look like? Well, it looks like this. This is so much more than just error 400 bad request, which is basically useless. Instead, we have a user message for the actual person looking at the screen. But even cooler is the model hint. This is an error message for the machine. It's a clue for an AI model or another automated tool on how to fix its request and try again successfully.
Let's just break this down. You've got the user message for the human. Simple enough. The model hint to guide the AI. The field tells you exactly which part of the request was wrong. No guesswork. And received shows you the exact bogus data that was sent. This is a total game changer. An error goes from being a frustrating dead end to being a helpful, actionable guide.
And this intelligence has to extend to our logs too. I'm not talking about just printing the line of text to a file. I mean structured logging, like this JSON object here. You have a unique request_ID, so you can follow a single request through your entire system. You know which tool failed. You know which retry attempt this was. This isn't just a log file anymore. It's a searchable, analyzable database of what went wrong. When things are on fire at 3 a.m., this is what saves you.
And of course, all this data is useless if you don't look at it. You've got to monitor these key metrics. What's your error rate for each tool? Are your retries actually succeeding? How often are your circuit breakers tripping? This kind of dashboard becomes the heartbeat monitor for your system's health.
All right, we have covered a ton of ground, so let's pill it all together. Let's distill it down into a simple, actionable blueprint that you can use on your next project. Here it is, your blueprint for resilience. First, classify your errors. Is it their fault or our fault? Then, implement that smart retry logic. Don't forget exponential backoff and jitter. For your critical external services, add a circuit breaker. It's a must. Learn to handle rate limits gracefully. Listen when an API tells you to back off. Make your error messages helpful, not just for people, but for machines too. Log everything with rich context. And finally, you have to monitor it all. If you check all these boxes, you're not just building code that works, you're building code that lasts.
So, I'll leave you with this one question to really think about for your own systems. Is your system just working, or is it truly resilient? Because there's a huge difference. A system that only works on a sunny day is fragile. A resilient one is built for the storm. So, which one are you building?
Thanks for diving into this with me. Next up, we're going to take this a step further and get into observability, how tracing, metrics, and logs all come together to give you X-ray vision into your systems. You don't want to miss it. See you then.